Imagine the vast Eurasian steppe, a landscape that stretches endlessly to the horizon, where the wind whispers through tall grasses and the sky seems to go on forever. This is a place shaped by millennia of history, where the earth holds secrets beneath every blade of grass and every rolling hill. For thousands of years, these plains have been silent witnesses to the rise and fall of ancient empires, to the migrations of peoples and animals, and to the stories that have shaped civilizations. The steppe is more than just a backdrop. It's a living archive of human and animal journeys, a crossroads where destinies have intertwined. Nestled within this expanse lies Arkham, a remarkable Bronze Age settlement that flourished nearly 4,000 years ago. Arkham was not just a village, it was a hub of innovation, culture, and metallurgy, where people crafted tools, traded goods, and built a society that would leave its mark on history. During excavations at Arkham, archaeologists uncovered the remains of a sheep. At first glance it seemed like any other animal bone, a simple remnant of daily life in the Bronze Age. But this sheep held a secret, one that would bridge the gap between past and present in a way no one expected. Inside the ancient bones, scientists discovered a microscopic stowaway, evidence of a pathogen that had traveled through time. This tiny organism, invisible to the naked eye, would soon challenge everything we thought we knew about the history of disease. Using cutting-edge DNA sequencing techniques, researchers were able to extract and analyze the genetic material preserved within the sheep's bones. What they found was astonishing. The genetic fingerprint of Yersinia pestis, the bacterium responsible for the plague. This discovery was more than a scientific curiosity. It was a revelation that connected the distant past to one of humanity's most infamous killers. The strain found in Arkham's sheep was not the same as the one that would later devastate medieval Europe, but it was a distant ancestor, a genetic forebear of the Black Death. This ancient lineage offered a rare glimpse into the evolutionary journey of a deadly pathogen. The implications of this finding rippled through the scientific community. It challenged the established narrative of plague history, suggesting that the origins of this disease were far more complex and ancient than previously believed. The story of the plague was no longer confined to the Middle Ages. It stretched back into the Bronze Age, woven into the fabric of early human societies. The evidence hinted at a world where animals and humans lived in close quarters, sharing not just shelter and food but also invisible threats. Sheep, goats, and other livestock were more than companions. They were unwitting participants in the spread of disease, helping pathogens leap from animal to human and back again. The sheep's bones became a time capsule, preserving a fleeting moment when a deadly microbe crossed the boundary between species. Each fragment of bone, each trace of DNA, told a story of transmission, survival, and adaptation. This chapter of history isn't about kings, warriors, or epic battles. Instead, it's about a silent, invisible threat that traveled with people and their animals, shaping destinies in ways that went unnoticed for centuries. The true drama unfolded not in palaces or on battlefields but in the quiet companionship of herders and their flocks. The sheep of Arkham was more than a source of wool, milk, or meat. It was a vessel, a living carrier of a pathogen that would one day change the course of human history. Its presence in the archaeological record is a reminder of the deep, often hidden connections between humans, animals, and the microscopic world. This discovery forces us to reconsider the past, to look beyond the obvious and explore the shared history of infection that has shaped our world. It invites us to ask new questions about how diseases emerged, spread, and influenced the rise and fall of civilizations. The Sheep of Arkham opens a new chapter in the epic of human and animal coexistence, a story where even the most unassuming creatures can hold the key to understanding our deepest vulnerabilities and our shared journey through time. What is Yersinia pestis, and why has it haunted the pages of human history for centuries? This microscopic organism, invisible to the naked eye, is responsible for some of the most devastating pandemics ever recorded. Yersinia pestis is a bacterium of incredible destructive power, a single-celled entity with the ability to alter the fate of entire civilizations. Its presence has shaped the course of wars, economies, and even the structure of societies. It was the unseen force behind the plague, a relentless killer that swept through continents, leaving devastation in its wake and reshaping human societies in profound ways. The Black Death, which ravaged Europe in the 14th century, was caused by a highly evolved strain of this bacterium. But this deadly form did not simply appear overnight. its origins trace back through centuries of evolution and adaptation. Earlier strains of Yersinia pestis existed long before the infamous pandemics, quietly circulating among animals and occasionally spilling over into humans. The Arcame sheep strain, discovered in ancient animal remains, represents one of these early versions. Unlike its later descendants, this strain lacked the deadly mutations that would make the Black Death so catastrophic. Crucially, it had not yet adapted to thrive within fleas, the tiny insects that would later become the perfect vehicle for its rapid spread among humans and animals. This adaptation was a turning point, allowing the bacterium to leap from host to host with terrifying efficiency. The ancient strain is like a biological fossil, a snapshot frozen in time that helps scientists map the evolutionary journey of the plague. By studying these ancient microbes, we gain a window into the past, revealing how small genetic changes can have world-altering consequences. By comparing the genetic codes of ancient and modern strains, researchers can trace the step-by-step process by which Yersinia pestis became more virulent and deadly. Each mutation tells a story of adaptation, survival, and the ongoing battle between microbe and host. This evolution is a stark reminder of the constant arms race between pathogens and the organisms they infect, a race that continues to this day. Understanding the history and evolution of Yersinia pestis is crucial for comprehending the nature of infectious diseases today. It informs our strategies for surveillance, prevention, and response to future outbreaks. The secrets locked within this ancient microbe provide invaluable insights into the origins of pandemics, reminding us that the story of disease is deeply intertwined with the story of humanity itself. The discovery of a plague in ancient sheep remains led scientists to search nearby human burial sites for further clues. They were determined to understand the full extent of this ancient epidemic. Could the plague have jumped from livestock to herders? This question drove the researchers to dig deeper into the relationship between humans and their animals. Ancient DNA extracted from human teeth provided crucial evidence. The analysis confirmed that humans were indeed infected by the same plague. 3 cases from the same era were identified, 1 in a sheep and 2 in humans. This pointed to a significant event in history. This was not just an isolated incident but a local outbreak, a zoonotic event where the disease crossed species barriers. Genetic analysis revealed nearly identical strains of the bacterium in both sheep and humans, serving as a molecular smoking gun. This groundbreaking discovery was the first direct evidence of livestock-to-human plague transmission, a significant milestone in understanding ancient diseases. Imagine a herder tending to a sick sheep, completely unaware of the deadly danger lurking in close contact. The bacterium could easily pass through close contact, spreading silently among humans and causing widespread infection. This intimate connection between herder and flock became a pathway for the plague to spread, intertwining their fates. The shared genetics of the plague bacterium tied the fate of sheep and humans across millennia, revealing a deep and tragic connection. This discovery paints a vivid picture of life and death on the steppe, highlighting the fragile balance between humans and their environment. The Arcame sheep wasn't the original plague source. Likely resides in a natural reservoir, a wild animal population. Modern reservoirs are rodents like marmots and gerbils. An unknown wild rodent on the steppe was likely the ancient source. The infection spilled over when other species contacted this reservoir. Sheep grazing over rodent burrows could encounter the bacterium. The sheep acted as an intermediate host, bridging wild and human populations. This hidden reservoir concept is key to understanding disease persistence. The Arcame sheep points us to the ecological dynamics of the steppe. Arcame's discovery highlights a shift in human civilization. The Bronze Age saw a transition to large-scale pastoralism. This created a perfect storm for infectious diseases to emerge. Close contact with livestock increased pathogen transmission opportunities. Sheep acted as amplifiers, spreading disease within herds. Herds became moving reservoirs, traveling with herders. This new lifestyle changed the nature of diseases. Pathogens adapted to survive in livestock, gaining an evolutionary edge. The Arcame sheep symbolizes a time when domestication invited plagues. Our success in managing animals inadvertently welcomed devastating diseases. How did the Bronze Age plague spread so quickly? The traditional model of rats on ships doesn't fit this era. The plague traveled on the hoof, with semi-nomadic herders. Migrations connected distant communities, spreading the disease. Infected flocks covered vast distances carrying. Pastoralist routes became superhighways for disease transmission. This model explains the plague's rapid spread across the steppe. The interconnected world of the steppe was a conduit for contagion. The Arcame sheep story is about civilization structure creating pandemic pathways. The Arcame sheep has shifted our study of disease history. We relied on human sources, missing the role of animals. Animal remains are invaluable biological archives. They hold genetic ghosts of past pathogens. This approach moves epidemics into historical ecology. Our choices influence our exposure to disease. The Arcame sheep teaches us to listen to the stories of animals. The Arcame sheep story has vast implications. It provides a crucial data point in the plague's evolutionary timeline. Studying its genome helps us understand pathogen emergence. Historically, it alters our interpretation of the Bronze Age. Pandemic disease may have influenced societal shifts. The discovery deepens our understanding of human-animal relationships. Domestication created new disease pathways. The past echoes in modern zoonotic diseases. The Arcame sheep connects us to a shared history of life. It reveals the invisible forces shaping our world. The Arcame sheep marks a new frontier in archaeology. Ancient animal bones are treasure troves of pandemic information. Researchers are searching globally for pathogen traces. This work could pinpoint the Bronze Age plague's wild reservoir. Beyond plague, it traces other zoonotic diseases' origins. This new field of paleoepidemiology integrates disease impact. Animal bones tell stories of coexistence and survival. Listening to these archives guides us to a healthier future.